quiz one real quick. Quick stats. 1 second. Oh, Luke. I called you. Did you not come? Here you go. I know. I called you, and then when you didn't come up, I just thought work here. I also have your. Hold on. This for you. So quick stats for us. Our average and our median were actually both the exact same score. So they were a 7, which is not bad. I mean, I guess 7's average, so it's not bad. I would have hoped for 8 for the first quiz, but it's not bad. That gives us somewhere to start, somewhere we can build on. A couple of things that I noticed with an alarming clip. The 2 questions that were the definitional out-of-the-book questions were missed at very high rates. When I say definitional out of the book, they're in the margins on the book, and they were taken straight from that definition. Missed at a very, very high rate. So right off the bat, I know that number can go up. Just a reminder, the quizzes, not only are they lecture material, they're your assigned readings as well. So make sure that you are keeping up with that in the book. I put where we are, up here every day. I also mentioned it several times throughout every couple classes. So make sure you're keeping up with that. Other things that I noticed where I know we can gain some points, the math question. Make sure you pay attention to which variable you're solving for. So in the question I put find market quantity. And a lot of people just went right through, solved for price, and left it. You had to take that price and put it into the Q into either equation, and it would give you Q. So again, just kind of watch that. There's not a ton of math on the quizzes, right? The test will have more math, but it's a math-based class, so you'll probably have stuff kind of like this appear, where, hey, you're solving. There's 4 choices. Make sure you're solving for the right thing with your choice. So just kind of keep an eye on that. The other thing that I wanted to look at a little bit more detail too is the equation questions. The ones where I gave you the big long equation. There were 2 questions for it. That we said essentially, one was find the incorrect sign, one was what do we know about the equation. So that's what I want to look at. There were multiple versions, so I can't just say go to number 5 because there were a lot of versions and everyone's number is different. So go to the question that had the big paragraph and the big equation. And then it said, okay, next 2 questions, right? So the first one, at least on this version, according to the above equation, domestic automobiles are. So what do we know about the domestic automobiles? So the first one, right off the bat, you can eliminate exogenous. Because the entire question is asking you to solve for domestic automobiles. We know it has to be an endogenous variable. So it can't be exogenous. So right off the bat, we get it down from 4 to 3 choices. Then I think what got a lot of people was that inelastic one. First of all, just kind of in general, we really probably would need a lot more information to determine it truthfully, if it was elastic or inelastic. But even based on the scale I gave you, without true full information, we should probably make an assessment. Because if you'll notice in the big paragraph where it says the variable description, price is measured in dollars. So this would be like saying every time the price of a car goes up $1, people buy 2 less cars. That's incredibly responsive. I mean, in fact, I would think it would be completely the other way, that if price of a car went up $1, we wouldn't even notice because no one looks at the last number on a car price. So by having that -2 coefficient there on price, it really, really is indicating very responsive behavior. Again, we don't have enough to calculate a true elasticity, but that indication of incredibly responsive seems to violate the definition. So there is that kind of element to it. And if that's the case, again, it probably is a wrong coefficient, but I didn't tell you anywhere to find me a wrong coefficient. I made it glaringly bad. So, again, so it would hopefully steer you away from inelastic. So if we scratch that out, that only leaves us with normal and inferior. And normal and inferior refer to the sign on the income coefficient. All you got to do is look and see what the sign is. Positive, normal, negative, inferior. So if you look at your income coefficient, negative 0.1y, tells me that it's an inferior good. The second one was based on the variable description. which one has a wrong sign of these choices. Now again, one of the choices is price. While the coefficient is probably way too high, the sign is correct, because law of demand says that Q and P have to have opposite signs. So if Q is positive, P has to be negative. Matches up. So then we need to go through the exogenous variables to see what we got off. At least on the version I have, the first choice is the price of foreign cars. So foreign cars are a substitute to domestic cars. We know that substitutes in our equation have a positive sign. So if we look at our term for foreign cars, it is positive. It's as expected. Give it a check mark. Next one on my version is gas. So gas and cars, that should be a complementary relationship. Remember, a complementary relationship, goods you use or consume together. You put gas in your car, they're going to be complementary, and we know that complementary goods have a negative sign, so if we look at gas, it's got a positive sign. So right there, that's our wrong sign. But just to kind of think about the other ones, car maintenance. Car maintenance should be a complementary good, right? Again, consume together. If you have a car, you're eventually going to have to get it fixed. And the negative sign says that if the price of maintenance goes up, you're less likely to buy a car. So the negative sign is kind of what we expect. And so that one shows us the correct relationship. And then advertising. Remember in class I said advertising almost always has to be a positive. It has to be a plus sign. Advertising tends to make you want the product more, which increases your demand. And then we even said, hey, for one person, yeah, maybe they don't like the commercial. But these people are very good at what they do with research. And they know, yeah, one person they've made upset, 80 people want the car more. So what does that mean for the market overall? People want it more. So we expect that plus sign in that relationship. Okay, so those were a couple that I really wanted to look at and talk about. If there's other ones you missed and you still want to talk about, by all means, let me know, talk to me after class, or stop by my office and we will definitely look at those. Okay, so let's put this away and get our notebooks back out. And I guess change gears isn't exactly the correct term, because we're still working essentially in that supply and demand model, but we're going to change how we think about that supply and demand model a little bit. I guess we're going to refine it in a better way, how we think about it, because up to this point I've just been really loose with how we interpret our model. Sometimes I said, oh yeah, so think about you as an individual and a person, would this make you more or less likely? And sometimes I was like, well, think about society overall, would this increase or decrease their purchasing? And so I've kind of just been really loose with assigning essentially some measure of population. Today we want to kind of address that and start stepping away from just thinking of demand as some individual function or some individual behavior, and start combining it into groups of demanders that are going to represent, well, an entire society or an entire market. So that's going to be our strategy for today. We're going to look at what we call market demand. And I'll give you a definition. It's more of a description, but it'll still work. Market demand is the sum of all individual demanders found within some market boundary. The sum of all individual demanders found within some market boundary. So sum kind of implies what we're going to be doing here. Sum means addition. We're going to be adding stuff. I'm going to do it two different ways, graphically and mathematically. When we do it graphically, sum is going to kind of be essentially horizontally adding our graphs. When we do it mathematically, we're actually going to sum down the functional map. So I think I'll do graphically first, because I think it's kind of just, it'll make the math a little easier once we see it. So I'm going to start out super basic. I only want 2 people in our market. Let's start with a real easy market. So we're going to have person 1, and we're going to have person 2. And I'm going to go ahead and give a demand curve for each of these individuals. And let's hypothetically say that person 1, maybe they have a maximum willingness to pay at right around 20. So I'll have a p-intercept of 20. Any price above 20, they won't buy the product. Even at 20, they're still buying 0. But as soon as price falls below 20, they'll buy it, even if we could talk like fractional. So $19.99, they're buying some fractional cube. Okay, and we also know that at a price of 0, if the good was free, there's some amount that they would want of the good. So again, arbitrary, made up, let's call it 8. And if we connect those, I've got the demand curve for person 1. All right, then we have person 2. And if I carry a value of 20 over to person 2, well, person 2, yeah, they're in the market. They'll buy this good at $20. Not only that, they'll pay more for it. Let's hypothetically assume that person 2 has a higher willingness to pay of, maybe say up here, 30. So we know there's going to be some positive Q at a value of 20. And if they're willing to pay more, we would probably assume, although you don't have to, but we would probably assume that if the good was free at a price of 0, they would get more of it anyway, because they have a higher demand for it. They're willing to pay more, they want it more. So maybe down here at, I don't know, 13. And again, I can connect these points, and I get demand curve 2. Where you'll notice at this price of 20, again, that positive value, let's call it 5. It looks like that would be about 5. 5 units of the good is purchased. So my art's not perfect, but it kind of definitely looks like person 1 is a little bit of a flatter demand curve than person 2. So maybe person 1, we see that less, willingness to pay, that more responsive. They'll be more responsive to a price change too. But that doesn't have to be something we truly think about or need. So I want to sum them together like the definition implied. I'm going to add person 1 and person 2 into some market demand. Okay, so put it all on one side of the board. If you're not a very good artist, you may want to just hold off on this one. I'll give you a moment at the very, very, very end to make sure you got it jotted down. But you may want to hold off. If you're pretty good at lining things up, or if you have graph paper, great. You're probably good to go. Okay, so here's what we want to do. We want to look at all of the prices that I have on the model. I've got enough. I can even add in more if we so desired. But and I want to see each behavior at each of these prices. So if we say, okay, well, what is the highest price I have so far? The highest price I have is 30. So if I carry 30 back to my original model and over to my market model, I can get a plottable point. Because, well, we know person 1, they're not even thinking about this good at 30. They're going to purchase none of it. Person 2, this is their market entry point. Well, they're not purchasing any at 30. As soon as price falls below $29.99, they're getting some fractional amount. So we know that right at 30, any spot below that, demand is going to exist. So that tells me that my highest price up here, 30, same thing. Any spot below that, demand is going to exist. So I know I have a demand curve coming out from that point. All right, next point, 20. Well, I've already carried it back. Let's carry it forward. All right, what's happening here at a price of 20? Well, at a price of 20, we already conceded person 2's in the market and they're buying 5 goods. We've got that key point. Person 1, This is where they enter the market. Now remember, at a price of 20, they're buying 0. It is still an intercept. But at anything below, they'll purchase the good. I can take that over and say, okay, so at $20, well, person 1 gets nothing. Person 2 gets 5 units. And I've got some point here, point B, that represents that connection of 5 units purchased total at exactly $20. Where if now I connect what I went ahead and named point A up here, and point B, I get this line segment AB, which is a demand curve. However, only person 1 is in the market at prices above 20. So line segment AB is market demand. But we have only one person in the market. We only have, right here, person 2, but only person 2 is in the market. After point B, both individuals will be in the market. So at point B, we know we get a new person entry. There's new market entry, person 1 enters. We call point B a kink point. And I'll give you a definition for it. A kink point is where the market demand curve changes slope due to more people entering the market. Where the market demand curve changes slope due to more people entering the market. So, I'll do it in light color, like green is fairly light, so I hope everyone can at least still see it. But just kind of to track the slope. And if you think it's going to confuse you or you only have one color, that's fine. Just leave it off. But if I kept the slope, this is a linear function, and I keep the slope from A to B, it kind of follows right along this path, right? And it would have an intercept right here. In fact, I even know that intercept. I know what it is. It would be 13. Because if it stays the exact same slope of only person 2 in the market, it would have person 2's demand curve. So I know that intercept right there of that imaginary green line would be 13. However, that's not the horizontal intercept of market demand. Because the horizontal intercept of market demand, found when the price is 0, would have to account for the 8 goods that person 1 wants and the 13 goods that person 2 wants. So 8 plus 13, right? We're summing things, so 8 plus 13 gives me a value of 21. 10, 15, 20. So kind of like right here. Got pretty close to the end of the board, but I made it. 21. I'm going to put a point right there, point C. Point C, our horizontal intercept or our Q intercept. When both people are getting their number of goods when the price is 0. So both person 1 and person 2 are getting their intercept value. Okay, so I've got now another connection that I can make. I can connect BC. So So you'll notice it's coming out at a different slope. Line segment BC is market demand with everyone in this case, because there's only two people in the market. So D, I'll even lose the M as we go on over the semester, but D for M for market. So it changed our slope. That's still fairly, I mean, it's only got one kink point and it's got two directions. It looks still kind of fairly straight. Yeah, but think about it in this sense. What if another person entered, and another person, and another person, and another person? Every single one of these persons effectively has a slightly different slope, which would mean it would keep changing the slope more and more and more and more and more. In fact, we kind of have, I will call it a quasi-formula to determine number of kinks. You notice I have two people and one kink point. Your kink points essentially are your population minus 1. You have 10 people, 10 minus 1, you would have 9 kink points in your model. So it's changing direction 9 times. Law of demand's still going to hold, so every time it's still downward sloping, but it's going to change more and more and more and more and more. It's going to make it much more and more and more nonlinear. We'll probably address that a little better tomorrow, because I want to do the math element of this. Okay, but before I do that, are there any questions on the graph part? Okay, I'll leave this up for just a second. I'll start erasing over there because I did say I'd give you a minute for bad artists to get that down now that we know what we're looking at. And while people are finishing jotting that down, for those of you who are already had it, think about it this way. So I've got A, B, C. I could put other points on there. Like I could have put a price of 10 on both and found out what quantity was at 10. And I could have put other one. And every single one of those points is an ordered pair combination, which means every single one of those points is mathematically solvable, just like we did last week whenever we had functions and said, hey, let's find some points on here. So we know that all of those points can be solved mathematically, assuming we know the functions to describe our demand curve. So I'm going to make up some functions, and then after I write them, I'm going to erase that. Does everyone have it who needs it? Once, twice? Okay. So I'm going to make up some functions. Let's say person 1 for whatever reason, when I do market demand, I usually put the exogenous first and then subtract price. Did that confuse everyone too much, or should I just do it how we're normally used to seeing it? Used to seeing it? Kind of, okay. So how about we say negative 0.5 P plus 5, and person 2, quantity demand can be negative 0.25 P plus 13. Arbitrary, made up. They might be demand curves for something, but I couldn't tell you what. We're doing what we just kind of did with math, but the numbers won't match up with the numbers on the old graph. In fact, I'm about ready to erase that, so assuming everyone, like I said, got it. No, these are totally just made up, okay? Kristen, to be honest, they're ones of math I can do in my head. That's where they're coming from. They're probably not realistic in real life. Okay, so I kind of like doing this in steps. So I'm going to write this for you in steps so you kind of have a checklist. So step 1, what do I want to do this? How about right underneath it? So step 1, we want to find each individual's price intercept. right? If you want the formal terminology, we're finding each individual's maximum willingness to pay. That's the formal. But what are we doing? We're finding the p-intercept for each. So I'm just going to kind of like just off to the side make a little column. P-intercept. Okay, so the p-intercept for person 1 would occur when q is 0. So I would need price to be 10 to make q 0. Because negative 0.5 times 10 is negative 5 plus 5 is 0. All right, person 2, I would need p-intercept to be 52. Because a fourth of 52 is 13, so negative 13 plus 13 is 0. Oh, good. This gives us a little bit of information. Just like what you saw on the graph, if you have to flip back and look at it, what did we notice? Whichever person had the higher willingness to pay, that number ended up becoming the intercept for the whole function. It became the p-intercept for the market demand curve. Right? It was person 2. They were willing to pay 30, so our market demand had an overall p-intercept of 30. Same thing is true mathematically. The biggest number is the overall p-intercept. So we know this is where the intercept will occur. Any other lower prices in our list are going to be kink points. Right? And again, we saw that in the graph. The first person was 30, second person was 20. What was 20 in the market model? It was a kink point. Okay, so I know this will be a kink. Okay, so that was step 1. Step 2. Step 2, I mean, we don't really have to do right now. I just like doing it right away, just to kind of help organize my model. I want to find the q-intercept. So we're going to find the q-intercept for the overall function. So the q-intercept, remember, the overall function was when p was 0. And then we just added up everyone's q's. Well, the way I have these equations stacked, this is going to be pretty easy. We can just add the exogenous value. So my q-intercept occurs at 18. Again, make price 0. 0 plus 5. Person 1 would want 5 if they were free. 0.25 times 0 plus 13. 0 plus 13. Person 2 would want 13 if they were free. Add them together. So q-intercept is 18. So now I know a couple of things. I know where my function starts, where it ends, and where it changes slope. At least partly where it changes slope. Because there's step 3. We need to find our kink quantities. More than one if we have more than one kink point. Yay? No? Uh-oh. I think I just unplugged it. It's working. Good?
Yeah.
You see? Although now, Emma, have I screwed you? Can you not see it all now?
No.
Okay, good. I don't know whose this is. Whose food so we can see better. Find the kink quantity. Okay, so how am I going to do this? Well, in order to do this, I have to do a couple of things. First of all, I need to find combined demand functions. I need to find combined demand functions for whoever is in the market. Find combined demand functions for whoever is in the market. Okay, so let's just kind of carry this up. Kind of go right here. So we know that our kink price is $10. Who is in the market at a price of $10? Well, person 2 is definitely in the market because they're willing to pay 52. So I know they're willing to pay 10. And this is where person 1 enters the market. So I know that this is where they're joining. So in this case, both are in the market in this example. So I want to find a combined demand for person 1 and for person 2. So if I have their demand curve, negative 0.5p plus 5 and negative 0.25p plus 13, I can add together I can sum together these functions vertically to get market demand. We did this in college algebra, somewhere along the line. It probably had a name where we sum functions. I don't remember it. But that's what we're doing, right? The definition said sum all your individual demanders. Okay, so if I sum each column vertically down, I would get plus 18. Sum each column vertically down, that's a decimal there, it's hard to see, and I get negative 0.75p. So now I have a combined demand equation where quantity demanded is equal to negative 0.75p plus 18. Okay, so what do? Well, I have a p, I need to insert a price. So I'm going to insert my kink price into that equation. So we'll put in the kink price. That gives me negative 0.75 times 10 plus 18. Negative 7.5 plus 18. Our quantity is 10.5. This is the quantity that my model kinks at. I can now plot and graph this. All right, so let's see. My overall p-intercept up here at 52. My overall q-intercept, we'll call it right here at 18. My kink point occurs when price is 10. That looks like about 10, 20, 30, 40, maybe a little lower. There we go. My kink quantity is occurring at a Q of 10.5. So let's see, if this is 18, half of that is right about there, so let's go a little bit more, let's call it right there. And I can put a point right there where I now have part of my demand curve coming down at this slope. And then it changes slope and continues out to 18. I hope I've made the slope distinction well enough that you can actually see the change in slope, especially the back row. I think the front people are okay. The back row, can you see the change in slope okay? Good? Okay. It's hard without graphing. So, so we've been able to find that market demand. Hopefully I'll have some good news to write there. Cardinals at the base is loaded. Okay, so last hour they threw out this question essentially. They were like, you got 2 people. What if you have more? We can do it with more. For simplicity, I said, let's just do it with 3 people. But you could do it with more than 3. You could do it with 1 million if you wanted to. It's a lot of work to do it with 1 million. But let's just do it with 3. So I'm gonna steal person 1 and person 2 over there, but I'm gonna add in a new person. So let's say now add in, how about this other person where we've got quantity demand is equal to, so they put me on the spot last time, so I picked a super easy number, negative P plus 20. Yeah, I know it doesn't look pretty like the other ones do, but again, I wanted something I could do in my head on the spot. All right, and then let's go ahead and say, all right, well, they're going to be in this market, so let's bring over these other people. Quantity demand is equal to negative 0.5p plus 5. Quantity demand is equal to negative 0.25p plus 13. Right, so I have, person 1, person 2, person 3. Nothing changes. We still go in the exact same step order. Step 1, find each of their p-intercepts, okay? So negative p plus 20, this has to be a price of 20 to get me a Q of 0. We've already done this one, that was 10. And we've done this one, that was 52. Okay? Rules are still in play, right? Same thing. The highest number is our overall functional intercept. So the highest number is 52. That's going to be our overall p-intercept. It looks like pint. So there, maybe I'll do p-intercept. After that, the other two tell me they are kink points. So we've got 2 kink points. One person is entering the market when price falls below 20. They're the first new person to enter the market. So the next highest price is where my first kink occurs. Kink 1 is at 20, thus kink 2 is at 10. Again, remember earlier I said to determine number of kink points, you take population minus 1. 3 people, minus 1, I'll have 2 kink points. That's what I got. Okay, so now I've got all my price, I've got all the prices there, all the kink points, we're good. Step 2, find the Q-intercept. How do we want to do that? We just wanted to add this column right here, right? 25 plus 13, 38. So now we know where my function starts, where it ends, we know the kink points. We got to go to step 3, find the kink quantities. Okay, this is where it gets a little bit different. We got to find the kink quantities. So if we go to kink 1, the price was 20. Who is in the market at a price of 20, right? That's what it says, demand curve, the combined demand curve for whoever is in the market. So who's in the market at a price of 20? Person 1 is, and person 3 is. They're the demand curve, the combined demand curve that I need to find. So I would take person 1, negative p plus 20, and combine that with person 3, negative 0.25 p plus 13. Sum them straight down, and I get a combined demand curve of negative 1.25 p plus 33. Okay, what next? Just like we did over there. Put in the kink price. Okay, so put in the kink price right there. Negative 1.25 times 20, if I'm doing this correctly in my head, is 25. So negative 25 plus 33. Anyone double checking my math, or are we just rolling that I'm right? That's fine, we can just roll that I'm right. And if I'm wrong and you figure it out later, that's on you. So negative 25 plus 33 is equal to 8.
Wait, what did you just do?
So what I did is, so we know that kink 1 occurs at a price of 20, right?
Yeah.
Okay, so then I said whose demand curve is going to be in the market? So person 3 and person 1, because they would be buying the good at 20. They're paying more than 20. So I just combined them to get the combined demand curve and took my price of 20, put it in for P. And this is where I was saying, that was I right in my math? This is 1.25 times 20, 25. I think it's, okay, good, see. So now we've just figured out the kink quantity. So kink point 1 occurs when P is 20 and Q is equal to 8. Kink 2. We know at kink 2, P is equal to 10. Who's in the demand curve? Well, at this point, all of them are. 1, 2, and 3. So I know that 1 and 3's combined demand was this number. So I'm just going to carry that, or this function, I'm just going to carry it down. Negative 1.25 p plus 33. Because that was already 1 and 3. Now I'm just going to add person 2's to it. Negative 0.5 p plus 5. Which means I get a combined demand curve of negative 1.75 p plus 38. Okay, what's the next step? Put in the kink price. So kink price here is 10. I'm going to put it into this combined demand curve. That gives me negative 17.5 plus 38. 17.5 plus 20 would be, so 20.5. So when I know kink 2 occurs when P is equal to 10 and Q is equal to 20.5. We could graph it. Since we only have like 3 minutes, can I just erase this right here and use the same graph? I don't want to confuse anyone about clearing the whole board. Okay, so we can graph this. Figure out these values, figure out what to keep that value. And I know what? Well, I know my overall p-intercept still here at 52. Perfect. I know that the first kink occurs at a price of 20. Okay, so like right there. Perfect. I know that my overall q-intercept is 38. So I'll make that, there we go, 38. Again, a lot easier with graphing. Kink 1. Kink 1 occurs when P is 20 and Q is 8. Okay, so like how about, let's see. All right, that'll be good. What about there? So I'm going to put a point at 20 and 8. There we go. That's where kink 1 is going to occur. I kind of find it's easier, at least for me, and because I'm terrible at art, so it may not be true for everyone. I kind of find it's easier to connect the dots as I go, and instead of wait until it's done and doing the dot to dot. But then if I do that, I usually end up getting horrible looking models. So I'm going to go ahead and connect that one. That's still kind of off. That's okay. Okay. I know that kink 2 occurs when price is 10 and quantity is 20.5. So 8, 16, somewhere right in here. So I'm going to put a point right there. Connect my next points. That one you can really see the slope change pretty well on, I think. And then finally, we know that my overall model intercept's right here at 38. So I'm going to connect those last points. And I get my market demand curve. Now with 3 people and 2 kink points. All right, questions on adding an extra person? If we wanted to, we could do it 77 times. It would take a lot of work. No, let's not do it. That would be like 4 days of work. We could though. 76 kink points, you follow the exact same strategy. Align the prices up from highest to lowest. Keep adding them into the model. All right, next time, real quick, we're going to finish our chapter 4 reading. So if you're following along in the book, on the syllabus, your science 4, we're going to be done with it by the end of next time. We'll do a little bit of extra market effects and then look at consumer producer surplus and market failure.